Good morning. My name is Mallon, and I am the CTO of Humanity. This is a slightly extended and re-recorded version of a talk I gave last week at COP28 in Dubai around supporting citizen science within war and conflict zones in the Ukrainian pavilion. So I have been an engineer for over 20 years in technology, working on code, innovation, data, consulting, etc. And during that time, I found that one of the best ways to tell great stories is with data. With the rise of artificial intelligence, that's created a massive opportunity to do so in a hyper-personalized way. So much so that I wrote a book on this called DKR, Dynamic Knowledge Rendering, which is out in a couple of weeks. If you would love a copy, then please just send me a message and I'll send you a free one as soon as it's available. Now, this talk is, or the project of which we did, is around war zone, conflict zones. But I just want to zoom out for a second to give some context for those who aren't familiar with citizen science and citizen scientists. There's been a rise in citizens basically conducting their own scientific experiments over the last decade because trust has just been slowly diminished in the world. Organizations, government departments across the world have neglected to present data, or sometimes have lied or have played in the gray area of reporting information, which has led citizens, particularly in the environmental sense, to go after the data themselves. We can see this article from The Guardian in November 2023, which talks about how Thames Water pumped 72 billion litres of sewage into the Thames in the last 3 years, roughly 29,000 Olympic-sized swimming pools. And this is a bit of a clickbaity article, but the problem with it is you see this line here. It says, water firms have no legal obligation to report the amount of sewage discharge, only the number of hours in which they released. Now, that means that we don't actually know how much sewage has been pumped into the Thames. This is an estimation from campaigners that have probably taken the volume of the outlet tubes with the speed of which the water goes and what the end pollution is once it's settled. But again, it's an estimation. So this, though, is valuable in campaigning and getting change. It also gives Thames Water a bit of wiggle room because there's just this lack of transparency. Why don't we just make it a requirement for them to report the amount of sewage? Now, because we have this type of situation, and this happens all over the world, citizens take it upon themselves to start reporting themselves. This is Dave Wallace. Dave is the co-founder of Humanity, and Dave lives in a town called Henley outside Reading in the UK. And Dave is an avid swimmer in the River Thames and has been doing for a long time. But this year, Dave's noticed that the river has become much more polluted. From the summer, Dave has been recording twice a week the nitrate levels and ammonia levels of the river and reporting it to a thing called Freshwater Watch, where Dave then got to meet other people doing the same things across different rivers across the UK. And also then, because of the publicity and the notoriety of what's been happening in the UK and the bad rivers we have, Dave's then been introduced to people around the world in conflict zones, in non-conflict zones, of the citizen science they've been doing. And all this data has been collected across rivers across the world, and it's massively valuable. But the problem is these citizen scientists are not technologists, they're not storytellers, and the raw data they're collecting, however valuable it is, it's not massively engaging. So we kind of have to ask ourselves, how can we make this data more engaging? How can we make it gain attention? Because when you're in a war or conflict zone, for example, or just you want to drive your message clearer, you're now competing against the TikToks, the YouTubes, the Instagrams, and etc. And you need to therefore tell a much better story. So we managed to grab some of this raw data around the Thames and able to feed it into an image model with some tweaks to produce images like this. So instead of showing you some nitrate levels on a graph around the river, I can instead show you this picture with the iconic Big Ben in the background, the House of Parliament, and then the River Thames not looking its best. But this gives a much more ephemeral reaction than a spreadsheet with a few numbers in it. And it's not just for situations where companies are not reporting data. It's also for the accidental kind of crises that we have in the world, such as rising sea levels. If we grab the rising sea level data and we run it against, say, Dubai, where we are here today for COP28, we get images like this with the iconic Burj Khalifa in the background. And we can see now this gives you a much more relatable, especially if you live in Dubai, it makes you think, oh, this is much more interesting than 4 words in a sentence of a 100-page report. Now, what has all this got to do with citizen science, with war and conflict? Now, this great work that people like Dave and people have done around the world with riverways, all this stuff tends to stop or doesn't happen when you're in a war and a conflict zone, because your objective is to stay alive for you, for your family, for your community. So citizen science doesn't happen, especially during the initial stages of a conflict. What we see on the outside world is we see infrastructure get destroyed, but nature tends to get left behind and just slowly degrades over time, because the key kind of aspects for monitoring nature have been drones and satellites. Well, as Victor from the Ukrainian Environmental Agency said, you can't release satellite imagery during a conflict because it gives military advantages out. Drones, for example, can be sent up by communities and can monitor wide areas for destruction. But the problem is drones have now become a combative nature in modern warfare. So they're being shot down prematurely, even if the drone is for just environmental monitoring point of view. So we wanted to do a mini kind of project to say, you know, what happens in a conflict zone when it starts? Where does the attention go? Where could AI help? And that's where social media actually came up as a potential solution. When a conflict happens, social media becomes this fury of images, of videos, of what's happening on the ground by the people actually there. So we wanted to ask ourselves, could social media act as our citizen scientist? So we did a project. And this project basically gathered the real-time images from a point GPS position, and then we were able to analyze them, and I'll go into the details. But by doing so, we can turn social media into actually a data store and present it to data scientists and engineers and storytellers to potentially tell a better story around the conflict from actual data backing. Now, all the images I show you in this research project are AI generated, because I can't actually use the images that we used, but I'll get to that near the end of the presentation. So first of all, we would search social media for a GPS point and we'd look for images of the conflict. Then we'd basically try and filter them images down to images that contained nature, like you can see here. The reason for this is because we want to track environmental damage over a period of time. And we grabbed images like this, and then we'd basically run it through what's called a segmentation algorithm like this. And then this here, as you can see, is highlighting all the different key aspects, the lady's shoes, coat, hair, but also buildings, trees, fields. And then we would take this, so this one image here has now been turned into, say, 50 images. And we take each of them 50 images and we run it through another algorithm. And that algorithm's purpose is to say, is this micro image nature or not? Is it a tree? Is it a field? Or is it a shoe? Or is it a building? And if it's not nature, then erase it. If it is nature, it gets to stay. And then we put all the images back together, and then we get this, which is an image that is just focused on nature. So from these 3 easy steps, we're able to go from an image of social media to an anonymized image representing the state of nature at that point in time, at that GPS position. And then we can monitor this over time. Now, as you can see here, these are all just from the same vantage point to make the concept easier to understand. But if we have GPS position and we have compass direction, we're able to do this from even images of different vantage points. And you can see here slowly the field is slowly starting to degrade, and we can see the degradation over the time. And then we can apply that across a much wider set of images across the city or region. We can then map them onto a kind of time series visualization of the city. And as you can see here, therefore, we kind of show that this part of the city is where majority of the image has been taken. The problem is that we can't use any of these images for research purposes, because when you take a photo, that photo is your copyright. If you then decide to share on social media, you still own the copyright of that image. And the social media channel has a right to use the image to show to other people. You as a viewer of the image can't do anything with it apart from look at it with your eyes. So we would like to advocate for the hashtag F4R, which is basically saying this image is free for research. This image has no kind of copyright added to it. You can use this for research purposes. And then the hope is that we can then create a library of images around a point in time that can be utilized in this way. And if we can do that, then the outcome becomes quite dramatic, because not only do we then get to take the images of social media and extract the natural habitats of them, we can then create multitude of different subsets of data sets for different organizations, different entities. We can have data sets that show that particular region. We can also just have pictures of how a field is degraded over time. And then we can map that information with, say, reports of missile attacks or chemicals used or fires that have happened, to understand what effects has happened to that field, and then running that through another model, determine, is the likelihood that crops are going to grow back in this field in the next 10 years, or does this field need to be repurposed for another use case? But the biggest thing is, as I think we saw in Nepal when the earthquake happened, they didn't know where to basically send humanitarian aid. They asked everyone to take photos and upload them, and then basically use them photos to position humanitarian aid in the right direction. This same thing can apply. If we had all these social media images and we were able to use them from a licensing point of view, you could basically work out, A, where the safe passageways were by analyzing the environmental effects, but also where all the people are and what the access would be. Now, if we have all this data and we have all of this raw insight, be it from sensors, be it from citizen scientists, be it from social media posts where we've extracted the insight, we can then turn that into better storytelling. Better storytelling maybe then can lead to change in conflicts. It may mean we can protect the environment better in these areas. It's a much more engaging message to have an interactive tool that shows the degradation of a river because of chemical effects in bombings. It's much easier to turn a image around the destruction of a field and crop yield into a storybook for kids that can just sow that seed over generations, or to generate a movie or a podcast or a art gallery or an urban planning plan. The data storytelling of all this can take a massive leap up if we have access to the data, and we can turn that data into stuff that both highlights the conflict, but hopefully in the long term reduces the conflict effects on the environment and maybe even the conflict itself. Thank you so much. My name is Dave Mallon. Any questions, please let me know.